So, Robert, are you online? I see you online.
Yes, I'm here.
Okay, Robert. So,
Yes, good morning.
good morning, Robert. So, our next speaker is Robert Bohn. His topic is fog and cloud computing. So, I'll give a brief intro to Robert Bohn. Dr. Robert Bohn works at the Advanced Network Technologies Division in NIS/ITL. He serves as the program manager for the NIST Cloud Computing Program. In this role, he manages and coordinates the goals and strategy of the program and also works with industrial, academic, and other government stakeholders to address requirements needed for the US government's successful and timely adoption of cloud computing as described in the NIST Cloud Computing Technology Roadmap. Currently, Bob is working with Dr. Tao Zhang of NIST in the development of a remote driving and vehicle teleoperation program. So, Robert, we invite you to give your talk.
Okay, thank you. Okay.
Yes, Robert, we can see
I
your screen.
presume you can see my screen. Thank you very
Yes.
much. I'd like to thank everyone for their attendance and for the organizers for inviting me to give this talk. Today I'm going to talk about the path to cloud federation via standards, and you will see during this talk that there's a direct applicability to edge and fog treatments and how that can be handled in the future via techniques used in cloud federation. So my next slide. So here is a brief agenda of what I'd like to talk about today. I'm not going to talk about the agenda right now, but I will come to say that we've been doing the NIST Cloud Computing Program first started in May 2010. We were charged by the US CIO to develop a cloud computing and technology roadmap for the US government. At that time, cloud was relatively new, and was decided that they'd like to get involved, that the government would like to get involved in that at the very beginning, so they could have some opportunity to weigh in on the process. So NIST was charged with developing a cloud computing roadmap that has 10 requirements needed for the US government to adopt cloud in a quick, safe, and secure fashion. And from that, what we had also developed a series of definitions on cloud computing at the same time. And one aspect of cloud computing is the community cloud. And that is a series that supports organizations that has a common set of interests, for example, a mission, security, a policy. And when that community cloud can't be implemented in a single cloud, then we have to define and implement ways to enable federation and interoperability between different cloud service providers. So that is the core requirement of requirement 5 in our roadmap, frameworks to support federated community clouds. So I'd like to lay out that the promise of federation is vast. We need to connect real-world collaboration needs with practical collaboration methods and tools. And federation will address how to securely manage these collaborations when resources are shared or inherently distributed. There's a wide spectrum of collaboration needs and approaches. One could think of bare bones federation, which is small scale, manually managed. Think of a couple of undergraduates in a dormitory setting who could set up their own type of federation with their own systems. We could go into much larger systems, industrial-sized federations that are highly distributed, automated, and use accounting, auditing, and other legal forms to proceed. So what is the essence of federation? The essence of federation is simple. I'm user A on the left, and I want to be able to use the services that service provider B delivers. So how am I supposed to do that? And how will I even discover the service on provider B? How can he manage his own discoverability? And then how can he validate my credentials and make access decisions? So this is the essence of federation. If I'm user A, the first thing I would want to do is to when I want to use services on my own system, I would go through my identity provider. He comes back, responds to me with a token. I use that with my service provider. He checks back with the identity provider to finally give me access. So that's within a system, but now how do I do this across systems? So as I just stated, NIST recognized the importance of federation, but also the IEEE recognized the importance of cloud federation themselves and runs a group called the P2302 working group, and that's on the standards for intercloud interoperability and federation. So between NIST and IEEE, we formed a cooperative effort to work up from ground zero, meaning no reference architecture, through the path of the standard. And the purpose of the IEEE standard is to create an economy amongst cloud providers. And an economy is something that you could buy and sell and trade, much like you could potentially buy and sell and trade services, compute, storage. This needs to be transparent to all the users and applications. It has to happen quickly, easily, and it has to provide for a dynamic infrastructure to evolve, to support evolving business models. The scope of the standard is relatively simple. It has to define topologies, functions, and the governance for cloud-to-cloud interoperability and federation. So on this slide, I'm showing what the goals and the outputs of each individual group are. The NIST Public Working Group will develop a cloud federation vocabulary and conceptual model. The interim outputs are contributed to the IEEE P2302 working group, and then in real time, in fact, and the output of the NIST group was a NIST special publication that's NIST SP 500-332. The IEEE, on the other hand, will develop a cloud federation standard based on that scope and purpose. So that group was able to give feedback to the NIST group in real time regarding vocabulary. The P2302 initial output will be an IEEE standard, and it will include a minimally viable API. And then finally, this IEEE standard will be submitted to the ISO JTC1 to create an overall international standard. This is a 3-plane model of cloud federation. So I'd like you to note that there are 3 planes here. The bottom plane is the trust federation plane, where everything begins. So if 2 site administrators, red and blue, want to create their own federation foo, they have to begin with trust. So they develop a trust model, whatever works for them, whatever sufficient for them in their individual federation. Next, they will go to a federation management plane, where each one of the federation managers will create a federation instance at their site Now, keep in mind that initially the Federation instance is empty. It has no members at all. They begin to populate their membership with their own people from their site. And then finally, Federation Manager A and B can create the overall Federation FOO, wherein all the services that are available to A and B are now available to all the users. Keep in mind, the services are not available to all the users without exception. These are role-based access systems, so I might have access to a service that you don't, and vice versa. So much like these are the essential characteristics of a cloud federation. In the NIST definition of cloud computing, there were 5 basic characteristics. Here, there's I'll just go over a few of the top ones. Federation is a virtual security and collaboration context that's not necessarily owned by any one user or organization, although you could form your own and then say it's yours, but it's not necessarily owned. Since only the specific users and sites collaborate for common goals, the participating entities have memberships in the Federation and identity credentials that are linked to each member. Users, sites, organizations can participate in a Federation by choosing to share some of their resources and metadata and making them discoverable and accessible to other Federation members. So it's up to you, or more correctly, it's up to the Federation governance itself to decide what type of metadata will be available, how people will share resources, how people will be paid back for resources or to recoup funds for resources. It may be a open federation with no such legal agreements or accounting associated with it, but it very well may be one of those. And finally, the participating members agree upon the common goals and governance of the Federation based on the well-known roles, attributes, and policies. In other words, when you're joining a Federation, you look at the governance. This is the rules of the road, what will be expected of you as a member or as an organization if you're giving resources to the Federation, what type of security you promise to uphold, and what type of other policies that you'll be adhering to. This is a figure of the NIST Cloud Federation reference architecture, which is in the NIST SP 500-332 I just mentioned earlier. That was published in February 2020. This is very similar to what the NIST Cloud Computing reference architecture is, and that was used as our beginning model. In that model, we had a cloud service provider, a cloud carrier, a cloud auditor, a cloud broker, and a cloud service consumer. So you could see in this architecture, it's much more encompassing, in which one has to also consider the regulatory environment and the administrative domain that you exist in. In addition, over here on the right-hand side, we have something which is unique to the Federation reference architecture, which is the Federation operator. The Federation operator is the individual who ensures that all the infrastructure is ready to hold Federation instances and be managed by a Federation manager. You could see the Federation instance covers several different types of characteristics. It has to maintain management, policy management, resource management, reporting and monitoring, accounting and billing, and it's important for portability and interoperability. Next slide. The IEEE objectives. So I mentioned earlier that the purpose was to create an economy amongst cloud providers, but more importantly, the IEEE work should be able to support a transparent infrastructure, much like the internet or like the phone network. It should also be cloud implementation independent, like an internet router, and then based on standards. A simple protocol set and easy to join is something that's needed. And like I said, to support regional governance, and that was shown in the this slide. There should be support for generalized resource federation, not just virtual machines, but also infrastructure as a service, platform as a service, anything as a service. If it could be extensible to describe any type of resource type that you might have, and communities can add their own resource types if they feel appropriate. There should be support for multiple or open or proprietary federation topologies. So how could we arrange them in the network? What type of topologies can be developed off of this? And then finally, in the big scale, it should be global scale capable. So here are a few of the possible initial small deployments. On the left-hand side, we have a third-party centralized trust model. And you can see the difference in the position of the federation manager. In the bottom left, the federation manager is internal to the federation, and in the top left, he is external to the federation. In more of a peer-to-peer model, at the bottom right, you see where you have two federations trying to communicate. Now, also in this case, it's important to realize this is where the interoperability between two federations will occur. So you still need to have an API that will address the use of that will allow the site users to communicate with the federation manager, but only in this case and the above case, you will need an API that will be truly interoperable and allow two federations to communicate. So if I dig down into the third-party centralized trust model just a little bit, I can see I have my members of my federation who come in through my federation hosting service endpoint, and then that is their commands are examined through the through the federation hosting service API server. If they're approved through the OpenID Connect server, then they can see if they're in the member catalog, what types of roles and attributes they have, and what type of services they have access to. If that's okay and comes through the policy policy access point, through the policy decision point to the policy enforcement point. Finally, if you can make it all the way through, you can get to the registered service, which is on the which is in the federation. Oh, finally, here in the bottom corner here, we have the federation hosting service operator and his API endpoint. Next slide. So I took out a lot of the detail from each of these federation hosting services just so I could focus on the final part of the federation hosting service to federation hosting service API. So in this case, this is where the real interoperability between two federation hosting services occur. They can be, well, we're actually working on this now to see exactly what type of requirements are needed to have two federations hosting services communicate. I'll leave some contact info at the end of the talk, so you can contact me or contact us through the IEEE. Finally, here's just one quick IoT use case on extending scalability for workflows. If I'm a service provider 2, I actually can create this federation manager here that will make a federation out of these 3 individual cloud IoT hubs, and then allow me to get data exactly from the type of IoT devices that I'm interested in. And so these would be shared. This data would be shared individually throughout a specific federation, whereas the other IoT nodes are not actually involved in the federation in this case. So with that, like I said, I'd like to leave the final slide here on how to find information. The IEEE P2302 Intercloud Working Group URL is listed right there. You can take a screenshot, or this will be archived later. My name is Robert Bohn. There's my email address. My co-chair, Dr. Marshall Michel, is at Data Machines Corp, and there's his email as well. So again, thank you for your attendance and your attention.
Thank you, Robert, for the excellent talk. So I think
thank you.
we have a time for a couple of questions. If either you or Tao can answer these questions, that'd be great. So I've been getting this. There are some questions on tactile internet. So there are a couple of questions. The first one is there a difference between fog and edge computing?
So there used to be quite significant differences when fog computing was initially started. And right now, I think that difference is reducing, is shrinking. And because the current definition of edge computing is getting closer and closer and closer to the definition of fog computing. Yeah, so that basically is my summary. And I see Flavio on the phone, and so it's, yeah, Flavio, you want to add anything?
Yes, can you hear me well?
Yes,
Yeah.
Flavio.
Can you hear me?
Yes.
So yes, I will talk about this in my little brief journey through the history of fog computing. And I will make some of these links clear between fog computing and what is edge, or even mission critical edge. In fact, the original vision was pretty broad and ambitious, and is being progressively realized, but it's taking its time. So there is a good amount of confusion in the names, and I'll talk about that a little bit in the transition between fog and edge that happened around 2016, 18. But now I think let's go for the edge. If anybody remembers fog, that's fine, but let's do the real thing, mission critical edge.
Okay, there's one question too. I think Robert can answer this. How do you plan to test federated services? Are there going to be any common test specifications and test-based licenses?
Well, thank you for that question. I don't have any plan to test to make such tests now. We are in the middle of developing an API, so federated services, that would be just the type of services. So some of the simplest ones that one of the first ones that I would really like to access is shared memory and storage. So again, this is a baby step, and what I think what the question is really a little further out there than what we're prepared to do at this time. I
Thank you.
understand this is important, but I'm not up there yet.
Thank you, Robert. So we'll move on to our next talk.